Welcome to Skywarn, severe weather training from NOAA's National Weather Service in Bismarck, North Dakota. I'm John Paul Martin, your warning coordination meteorologist. In this segment, we'll talk about thunderstorms, thunderstorm ingredients, their life cycle, and thunderstorm categories. There are basically three things we need to get thunderstorms: moisture, lift, and unstable air. Moisture, preferably in the low layers of the atmosphere, and think of that as higher humidity. We need to lift that moist air to get those parcels of air rising. And oftentimes in North Dakota, during the summer season, cold fronts provide the lift that we need. And finally, we need those moist parcels of air, once they start rising, we need them to keep on going. An unstable atmosphere will encourage those parcels to keep on rising until we get clouds to form and maybe even a thunderstorm. The number one source of moisture into North Dakota in the summertime is the Gulf of Mexico. Moisture from the Gulf of Mexico comes up ahead of cold fronts into North Dakota. Another source of moisture you may not think of is crops. Crops take a lot of water out of the ground and put that water into the atmosphere. That's called transpiration. Again, fronts provide the lift that we need to get parcels of air rising. Warm fronts provide gentle lift, but it's the cold fronts we're more interested in. At a cold front, the upward motion is more abrupt, increasing the chances of getting showers and thunderstorms to develop. Finally, unstable air. When a parcel of air is warmer than the air all around it, that parcel of air will start to rise. Rising air cools off as it lifts up through the atmosphere, but as long as it stays warmer than the air all around it, that atmosphere is considered unstable and that parcel will keep on rising. It'll keep on rising until it becomes equal to or colder than the air all around it before it starts to sink back down toward the ground. Again, we need an unstable atmosphere to grab those moist parcels of air that are lifted by those fronts and keep them rising until we get those thunderstorms to form. Thunderstorm life cycle. Thunderstorms go through a life cycle just like you do. They're born, that's called the towering cumulus stage. Motion here is upward. And when we start to transition from the towering cumulus stage to the mature stage is when we get our first flash of lightning. This mature stage is called the weather stage. It's where you're getting your lightning and thunder, rain, maybe some hail and high wind, and even flash flooding and tornadoes. In a thunderstorm that's mature, we have one main area of upward motion, that's the updraft, and one main area of downward motion called the downdraft. What goes up must come down. The updraft encourages parcels of air to rise up through the thunderstorm along with rain and hail, and that precipitation falls out where the air is moving down in the downdraft. When the warm, moist air gets cut off, the thunderstorm starts to weaken and eventually will die. It's still dangerous in the dissipating stage because there's still lightning, and lightning is a killer. Thunderstorm categories we'll take a look at: single cell, one thunderstorm; multicell, that's a group of thunderstorms. They can get together in a cluster or line up. In this middle picture, it's not one thunderstorm, it's 1, 2, 3 thunderstorms. We have 3 separate areas of upward motion. 3 thunderstorms making a multicell cluster. And then on the right-hand side is our supercell. What makes a supercell thunderstorm, which is the most dangerous, encourages severe weather, large hail, high wind, and flash flooding, along with tornadoes. What makes that supercell a supercell is that the updraft in the storm is actually rotating. So when you look up at a supercell thunderstorm, you may say, gee, it looks like that whole storm is rotating, and indeed it can be. Here's our single-cell storm. These storms typically do not last very long because the updraft and the downdraft are too close to each other. The downdraft chokes off the updraft, and the storm cannot continue for too long, and it most of the time cannot grow very strong. It can be pulse severe. It can produce large hail and some high wind in a pulse type fashion. In other words, it grows stronger and then it weakens, grows stronger again, and then it weakens. Kind of like when you take your pulse and feel that thump, 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 getting stronger and then weakening. The Multicell Storm, in this picture, it's not one thunderstorm. It's a cluster of storms. On the left is the towering cumulus stage. That storm is just being born. Towards the middle is the mature stage, and on the right-hand side is the dissipating or dying stage. As this thunderstorm dies out, a new one forms here. As this thunderstorm dies out, a new one forms here. Again, these individual storms are short-lived, but the entire system is very long-lived because, again, as one storm dies out, another one forms. Flash flooding is a main threat with these multicell storms. Here's a picture out ahead of a line of thunderstorms. And this wedge-shaped cloud is called a shelf cloud. It marks the gust front. It's where the warm air is flowing into the storm and the cool, moist air is flowing out. Where the two interface, we get this strange-looking shelf cloud to form. When you see a shelf cloud coming toward you, you should expect a change in the wind direction and an increase in wind speed. Here's another schematic of a multicell line of storms, a squall line. Again, here's our warm air flowing in and up into the storm, and the cool, moist air flowing out. Where the two intersect, where they interface here, we get this strange-looking cloud, wedge-shaped cloud to form, and that's called our shelf cloud. It marks the gust front. Here's a picture of a shelf cloud from the Richardson area of North Dakota. Again, when you see something like this coming toward you, keep in mind the wind is going to shift and it's going to increase in speed. Oftentimes on a shelf cloud, we get fingers of clouds sticking down that some folks mistake to be funnels or even tornadoes. To be a funnel cloud or a tornado, this finger must be spinning. In this case, along this shelf cloud, these fingers of clouds are not spinning. They are not funnel clouds. They are not tornadoes. Bow echoes and squall lines often form on lines of thunderstorms. In this case, this part of the line of storms is moving out faster than the rest of the line. Maybe the wind is pushing the storms here along at, say, 50 miles an hour, whereas to the north up here and to the south, the storms are only moving at 30 miles an hour. So with a 50-mile-an-hour movement here, this center part of the storm moves out ahead of the rest. It takes on this bow shape, like a bow and arrow. Here's a bow echo moving over the Minot Air Force Base, outlined here in white. The radar is off to the right of the screen. It's the Minot Air Force Base radar located near Deering, North Dakota. In this image, the radar has detected motion away from the radar here, so it painted it red, but motion toward the radar here in green and blue, so it painted that green and blue, the motion again toward the radar. This is a line of thunderstorms here moving through the Minot Air Force Base area. The radar indicated above the Minot Air Force Base at 1,121 feet above the ground, so 1,121 feet above the Minot Air Force Base, the wind was blowing at about 120 miles an hour. The question is then how much of that wind is making it down to the ground, and indeed measured at the Minot Air Force Base this day was 93 miles an hour. So not all of that wind was making it down to the ground. There was tremendous damage in the area as this bow echo squall line moved through. Supercell thunderstorms are highly organized. The updraft is extremely strong. And what makes a supercell separate from other thunderstorms is that the updraft in the storm is actually rotating. There's a high risk of severe weather with supercells. And only a small percentage of supercell storms spawn tornadoes, but the majority of violent tornadoes in the United States develop from these supercell storms. They bring all types of severe weather. Here's a schematic of a supercell storm. The storm is moving off to the right. On the right-hand side of the screen, the front side of the storm, is our sinking air. We call that the downdraft. That's where you might see one of those wedge-shaped shelf clouds. That's where the rain and hail is falling out. The visibility here will be very low because of the rain and hail falling out there. Your visibility will be lower because you're looking through the rain and hail. Towards the back of the storm is the updraft. Under the updraft, there's very little, if any, precipitation falling out. So this will be a bright sky here. You'll be able to see daylight through the bottom of the storm in this area, again under the updraft. The part of the storm where there's very little, if any, precipitation falling out, again under the updraft, that's called the rain-free because, again, very little, if any, precipitation, and base because it's the bottom of the storm, the rain-free base. Here's a picture of what that might look like in real life. Again, under the updraft, you can see daylight through the bottom of the storm because there's very little, if any, precipitation falling out there. This marks the anvil of the storm, and this bubble of cloud above the anvil is called the overshooting top. This upward motion in the storm is so strong it broke through the anvil and it's coming out the top. Again, called an overshooting top because it's overshooting the top of the storm. It's overshooting the anvil. Near the rain-free base area, oftentimes there's a lowering of the rain-free base into what's called a wall cloud. Sometimes this wall cloud will start rotating, and occasionally a funnel cloud or tornado will drop out of the wall cloud. That's typically towards the back of the storm, again under the updraft. And just because you get a supercell storm does not mean you'll get a wall cloud. Just because you get a wall cloud does not mean the wall cloud will start rotating. And just because you have a rotating wall cloud does not necessarily mean you'll get a funnel cloud or a tornado. But getting a supercell storm increases the chance of a tornado. Getting a wall cloud further increases the chance of getting a tornado. And getting that wall cloud to spin, getting that wall cloud to rotate, even further increases the chance of getting a tornado. The rotating part of the updraft within a supercell thunderstorm is called a mesocyclone. Again, you look up at a thunderstorm and say, gee, it looks like that whole thunderstorm is rotating. And if it's a supercell, it is indeed the entire thunderstorm rotating. A wall cloud is a lowering beneath the rain-free base. It's often rotating, and it marks the updraft into the thunderstorm. To the right of the picture, it's raining, and the rain-cooled air with the downdraft is coming down and then being sucked back into the thunderstorm right here, forming the wall cloud. This is our rain-free base of the storm. Again, our rising air, our sinking air. And this sinking air, this rain-cooled air, is coming down and being sucked back into the thunderstorm right there, forming our wall cloud. I want to thank you for watching this segment and ask you to stay weather ready.